Hi there, my name is Emmy and I'll be your guide for your last module of Day 4. I'll be talking to you about stationary points and sketching quadratic functions. Please pause this presentation at any time when you need more time to think about something. A positive gradient indicates a function is increasing. Here you see an example of an increasing function. If the derivative of the function is positive on an interval, then the function is increasing on that interval. A negative gradient indicates a function is decreasing. Here we see a sketch of the decreasing function. And as you might have figured it out, if the derivative of the function is negative on an interval, then the function is decreasing on that interval. A gradient of 0 means that the curve is flat at that point. This point is what we call a stationary point. There are two types of stationary points. One is turning points and the other is points of inflection. These can be found by letting the gradient equal to 0. A turning point is a point at which the gradient is 0 and where the gradient from left to right through the turning point changes sign. This could be from a positive gradient to a negative gradient or vice versa. A point of inflection is where the curve is flat but there is no change in signs. Here are examples of turning point and a point of inflection. The graph of a quadratic function is a parabola, as it was mentioned in the previous model. This means that it has one turning point and no points of inflections. The turning point can either be a maximum or minimum point. That is, a point where the function takes a maximum or minimum value. If the coefficient of x squared is positive, then the parabola is upright and the function has a minimum point. We call the shape concave up. If the coefficient of x squared is negative, then the parabola is upside down and the function has a maximum point. We call this shape concave down. Now let's present to you some examples. For the quadratic function y equals to x squared plus 2x plus 3, we want to find the minimum y value. First, we find the point that the gradient is 0. Do this by differentiating the function and set the derivative to 0. Then solve for x. You get x equals to minus 1. Substitute x equals to minus 1 back into the original equation to find the corresponding y value. When x equals to minus 1, y equals to 2. Since the coefficient of x squared is positive, minus 1, 2 is a minimum turning point. Hence, the minimum value of y is 2. Let's have a look at another example. We want to find the maximum value of the function 6 minus 2x squared. First, differentiate to get minus 4x. Then let it equal to 0 and solve for x. You get x equals to 0. So there is a stationary point when x equals to 0. When x equals to 0, y equals to 6. Since the coefficient of x squared is minus 2, the parabola will be concave down. So 0, 6 is a maximum turning point. Therefore, the maximum value is 6. Here are some practice questions for you to do. Press pause to attempt the questions and press play to see the answers. Here are the answers. Pause to check your answers and press play to continue. To sketch a graph of a quadratic function, it is good practice to label the turning point and the intercept with the axis. To find the y-intercept, that is where the curve crosses at the y-axis, we let x equals to 0 and solve for y. To find the x-intercepts, let y equal to 0 and solve for x. Note that there might be no x-intercepts. Let's consider sketching y equals to x squared minus x minus 2. Since the coefficient of x squared is positive, the parabola will be upright and there will be a minimum turning point. The minimum value occurs when the derivative is equal to 0. That is, when x equals to 0.5. Now, substituting x equals to 0.5 to the original function, we find that the corresponding y value is minus 2.25. So the minimum point is 0.5 minus 2.25. Next, let x equal to 0 to find the y-intercept. We get y equals to minus 2. So the curve crosses at minus 2 on the y-axis. To find the x-intercepts, let y equal to 0, factorize, and then solve for x. We get x equals to 2 or minus 1. This means that the curve crosses the x-axis at 2 points, x equals to 2 and x equals to minus 1. Here is a sketch of the function. Note that all the intercepts and the turning points are clearly labeled.